In this lesson, we'll discuss solving right triangles and what that means. So over here I have a right triangle because one angle is 90 degrees. And let me label this as, well, I'll say this is angle A, this is angle B, and the right angle is angle C. And it's usually written that the sides opposite the angles are just the lowercase letters. So this is going to be side A, side B, and side C. The idea of solving a right triangle is, if you're given some information about this triangle, like maybe the size of this angle and the length of this side, can you figure out the remaining angle and the length of the remaining sides? So just to have something to look at, like maybe angle A is, 30 degrees. So that's the size of this angle here. And maybe you're also given the length of side B is equal to 21. 21, some units, maybe centimeters or something like that. So we know this. Well, using all this information, can you figure out what angle B is approximately equal to? Or side A? Or side C? If you can find the remaining information, that means you have solved the right triangle. To do this, we're going to have to use some right triangle trigonometry. So that is, we're going to have to use, sine, cosine, possibly tangent. And the way they're defined on a right triangle is sine is the opposite over the hypotenuse, cosine is the adjacent side over the hypotenuse, and tangent is the opposite over the adjacent. So if you pick an angle like A, and you want to know what sine of this angle is, well, it's the length of the opposite side divided by the length of the hypotenuse. So that will be really useful also in trying to solve these right triangles. Before we actually solve a right triangle, I'd like to get some practice using inverse trigonometric functions to solve equations like this one and this one. So here in example 1, I'd like to solve the following equations for an angle theta between 0 and 90 degrees, and I want to round my answer to the nearest tenth of a degree. Let's start with this one over here. Sine of theta is equal to 0.15. There must be some angle between 0 and 90 degrees that makes this thing a true statement. Well, how do you find it? What's it equal to? What we can do is use inverse sine to cancel sine on the left, leaving us with just theta. It would look something like this. You could use either notation you want, but I'm going to use the sine inverse notation. And what I'm going to do is apply sine inverse to both sides of this equation. So I'll have sine inverse of, and I'll just put sine of theta here. And on the other side, I have 0.15. If these are equal, so are these because I did the same thing to both sides of my equation. The way we define sine inverse is sine inverse of sine of theta cancel, and it leaves you with just theta. And on the other side of my equation, I have sine inverse of 0.15. And this means you actually solve for theta is equal to whatever number this is. I can now go to a calculator and type this in to get my answer for theta. So I have a calculator here. It's asking for this in degrees, so I'm just being careful to make sure that my calculator is in degree mode. It is. I'll type sine inverse of 0.15. And the angle that I'm getting back, theta is equal to 8.6269, and it goes on. And it's asked to round to the nearest tenth of a degree, so we're rounding here. Our answer is theta is equal to 8.6, and since my calculator is in degree mode, this is degrees. And this angle meets the requirements in the question. It's greater than 0 degrees, and also less than 90. The way sine inverse was defined was to give us an angle back between negative 90 and positive 90 degrees. Since we have a positive number here, I knew we'd get a positive answer, and so everything worked out. We can use almost the identical logic over here on cosine theta equals 0.78. The only difference is I'm going to apply cosine inverse to both sides of my equation. So this one will look like this. I'm going to take cosine inverse of both sides of the original equation. So I get cosine inverse of cosine of theta is equal to cosine inverse of 0.78. That must be a true statement. I'm doing the same thing to both sides of this equation. But over here, cosine inverse of cosine, they cancel, leaving me with theta. And theta is equal to cosine inverse of 0.78. Again, at this point, you would go to your calculator, and let's see, cosine inverse of 0.78. Okay, I'm getting that theta is equal to 38, it goes on, but 0.739 dot, dot, dot. The fact that my calculator is in degree mode means I'm going to round here, but we get 38.7 degrees approximately. So this is the solution to this original equation, and this is also between 0 and 90 degrees. The way cosine inverse was defined is to give you an angle between 0 and 180 back. And it just so happens here that we have one that is less than 90. So we have met the requirements of this problem, and we found the corresponding angles. We are going to use this process when solving right triangles. All right, so we're going to solve a right triangle here. Let's say that we know the measure of angle A is about, we'll say 39.7 degrees. So I know this angle here is 39.7. Let's say we also know the length of side B is 36. So that is this side here. With just this information, can we figure out, well, what's the measure of angle B? What's the length of side A? What's the length of side C? If we do those three things, we have solved this triangle. All right, well, for starters, if we try to figure out the measure of angle B, I want to know the measure of this thing here. I don't think we really need to use any trigonometry to do this. I know the following fact. The three angles in a triangle add up to 180 degrees. So I'm going to write this down as, well, if I take A, the angle A, add it to angle B, and add it to angle C, it is a fact that these three angles must sum to 180 degrees. And if I plug in the fact that C is equal to 90 degrees, and I subtract 90 degrees from both sides of this equation, so take away 90 degrees, we get that the other two angles, A and B, must also add to 90 degrees. Not too surprising there. If these two add to 90, another 90 would take me back to 180. I can use this fact to use angle A to find the measure of angle B. So what is the measure of angle B? B is equal to 90 degrees minus whatever A is equal to, which is 39.7 degrees. So the answer is 90 minus 39.7, and we get 50.3 degrees. So that is this angle here. This is 50.3 degrees. There are only two things left to solve for. That is the length of side A and the length of side C. I'm going to try to find, I guess I'll work with this one first, the length of side A. To do this, I'm going to use some right triangle trigonometry. So what I'm looking at is, I'm also going to choose to use this angle A because it was the given information, but I want to somehow connect a trig function with this angle and that side. I can't use one that uses C because I don't know what that is, but I have to choose one that uses B. And I think I know which one that is. Tangent of any angle is defined as the opposite over the adjacent. So just using the letters, tangent of angle A is equal to A divided by B, the opposite over the adjacent. I can now plug in the given information into this equation. That means tangent of 39.7 degrees is equal to A over 36. This is very simple to solve for A now. I can multiply 36 to this side of the equation, and then I'll have A all by itself. All right, so let's do that. I have 36 times tangent of 39.7 is equal to A. My calculator is already in degree mode, so I'm just going to type in 36 times tangent of 39.7. Let's see what we get. And I get, rounded to the nearest hundredths place, I get 29.89. That's A. That's this. So just to recap, I didn't know the length of this side, but I did know the length of this one. So I said tangent of A equals the opposite over the adjacent. That's this equation here. I plugged in the given information. Everything was a number except for this A. I solved for A, and then I got my answer from the calculator. This leaves me with one last thing to find, and that is C. Now we have a right triangle, and you could use the Pythagorean theorem, but I'm going to try to use another trig function and do a process like this for some practice. So nothing wrong with using the Pythagorean theorem. That's totally fine. But what I'm going to do is somehow connect this angle, and let's say maybe I'll use this side to C. So here I use tangent. It's got to be a different trig function. I think if I do cosine of this angle, it'll work. Cosine is the adjacent over the hypotenuse, and the only thing I don't know there is C. Let's write that down. So that is, if I take cosine of angle A, that's equal to B over C. If I plug in all of the given information, that's cosine of 39.7 is equal to 36 over C. The only thing I don't know is C. But what I can do is multiply this C over here and divide the cosine of 39.7 to the denominator. I'm going to swap the location of these two things. This equation is equivalent to C is equal to 36 over cosine of 39.7. The rest is just going to my calculator and rounding to 2 decimal places. 36 divided by cosine of 39.7. If I round to 2 places, I get C is equal to 46.79. So I'll write that over here. That's 46.79. And I've solved this right triangle. I've solved it because I know every angle and the length of every side. All right, so again, I want to solve a right triangle, so I have one set up over here. This time, let's say this is the given information that we know. Let's say we know that the length of side A is equal to, we'll say 13, and we'll say the length of side B is equal to, I'll say 23. And let's say what we don't know is, well, I guess everything else other than angle C. Like we don't know A, I don't know the measure of angle A. I don't know the measure of angle B, I don't know that. And I don't know the length of side C. So I don't know those things. Okay, well in this case, how do I solve the right triangle? I think a good starting point is, if you know 2 sides of a right triangle, you can use the Pythagorean theorem to solve for the remaining side. So, we could do this as our first step. So let's just try it out. Let's see what happens. I know that a squared plus b squared is equal to c squared in every right triangle. So this is 13 squared plus 23 squared is equal to c squared. Let me start simplifying this a little bit. 13 squared plus 23 squared, that is 698. And if you want to solve for the value of c, we will take the positive square root of both sides. Technically there's a negative, but negative lengths don't make sense. So we get, okay, if I round to 2 decimal places, we get that c is about 26.42. So that is the length of this side here. So I have C, I have that figured out, and that came from the Pythagorean theorem. And just to label the other stuff in here, I knew that A was equal to 13 and B was equal to 23. That leaves us with finding the measure of angle A and the measure of angle B. we're going to have to use an inverse trig function to figure this out. So here's what I mean. Let's say we want to solve for the measure of angle A. And let's say we want to use these two sides that we know to help us do that. We could use this side, there'd be nothing wrong with that. But if you want to connect the measure of angle A to side A and side B using a trig function, tangent of A is defined as the opposite over the adjacent. So this time, tangent of A, capital A, the angle, is equal to 13 over 23. This equation is different because the thing I don't know is within inside the function tangent. If you want to find the angle A, what you're going to have to do is apply tangent inverse to both sides of this equation. And the reason for this is, well, tangent inverse of tangent of A is going to equal A. It's going to be some angle that is going to be between 0 and 90 degrees, which, by the way, is perfect. These two angles must be between 0 and 90 degrees. On this side, I'm just going to type in 13 over 23. So in my calculator, I'm going to type tangent inverse of 13 divided by 23, just like this. My calculator is currently in degree mode, so it should give me my answer. And if I round to the nearest tenth of a degree, I get 29.5 degrees. That's the measure of angle A. So that was using an inverse trig function. You could have used sine, you could have used cosine. I chose to use tangent only because it came from the given information as opposed to one of the first things we solved for. Okay, that leaves us with one other thing. What is the measure of angle B? Here, I'm going to use the fact that, well, if you add up the three angles in this triangle, it has to sum to 180 degrees. And since C itself is 90 degrees, it must be that A plus B also equals 90 degrees. So if you know A, B must be equal to 90 degrees minus what we got for A, which was 29.5 degrees. So 90 minus 29.5 is 60.5. And that is the measure of angle B. But here we've done it. We found the remaining side and the two other angles. So that means we have, in fact, solved this right triangle.